Good evening, children. I am Prasanna, a mathematics teacher. In today's class, we are going to discuss about relations and functions of class 10. It is the first unit in your book. So, these relations and functions are nothing but the extended version of set language. So, before learning these relations and functions, we need to quickly recall the basic concepts in set language. First, let us see what is a set. A set is a collection of well defined and distinguishable objects. So it's nothing but a set is nothing but a collection of objects. Set is nothing but collection of objects. Let us take an example. Set A equal to the set of all natural numbers. The set A is the set of all natural numbers. As you can see, each and every element in the set are very well defined. See, this is one representation of a set. This is another representation of a set. This I am writing it in the form of a sentence, and here I am writing it in the form of elements. Okay, these are representations of set. I will explain you that. As you can see, each and every element are different, and at the same time they are very well defined. So this is considered as a set. We can give too many examples for this set language, that is set. The set of all farmers in a town, the set of students in a class, set of states in India. We can give uncountable number of examples for this set. You also need to know which is not a set. That's much important. Let me give you an example, explain it with an example. The set of set B equal to the set of beautiful flowers in the garden. The set of all beautiful flowers in the garden. Here, these two words, beautiful flowers, it's not clearly defined, because in my opinion I like rose. In another person's point of view, he may like lily, and another person may like lotus, isn't it? So here the opinion differs. We cannot say which flower is beautiful and which does not look beautiful. We can't say like that. Here the statement is not clearly defined. So this is perfectly not a set. So a set should be well defined, and at the same time it should be distinguishable. That we consider as a set. We can give uncountable number of experience for this not a set also. The set of all good movies, it's not a set. The set of good students in a class, it's not a set, isn't it? And the set of tall persons in class, it's not clearly defined. Tall what? Taller than what height? It's not mentioned clearly, isn't it or not? Or taller than whom? It's not mentioned clearly. So those are not sets. We cannot consider those things as sets. Okay, so this is the definition for a set. Next, we are going to see about representation of a set. As I told you, a set can be represented in different forms. I have mentioned you two different forms here. The first one is descriptive form. The second one is roster form. And the third one is set builder form. Descriptive form. It's so simple. The set is explained through a sentences like this. The set of all natural numbers, the set of all whole numbers, the set of students in a class, set of states in Tamil Nadu. They are expressed through a sentence. The set is expressed through a sentence. This is nothing but descriptive form. The second one is roster form. You can see the second example. The elements are directly written inside the braces. As you can see, these two are the braces, and the elements are written inside the braces. So this kind of representation is nothing but roster form. This set builder form is also a notation in a mathematics for describing a set by enumerating its elements or stating the properties. Okay, that each member must satisfy. That is, we use a law or a formula to mention or to define a set. Okay, that each and every element in the set must satisfy that. That is nothing but set builder form. Say for example, I can write the same thing, the set of all natural numbers. Let me take a set. Example for set builder form. Okay, set A equal to x such that x. This x denotes each and every element of natural number. So x such that x belongs to n. That's all. So x is what? A natural number. The set of all natural numbers. Suppose if it is mentioned less than or greater than, we can also use the symbols like lesser than, greater than, or equal to signs to define the set. So I hope it's clear. A set can be represented in three different forms: descriptive, roster, and set builder. Descriptive, it's nothing but explaining it through words, and roster, it's nothing but uh, writing the elements directly. And the set builder form, we use a separate method to represent a set. Okay, and we have different types of sets also. See, don't get confused between the representations and types. Representation is nothing but how we show a set, that is representation, and the types of set is nothing but the different kinds of set. We have different kinds of set, like finite set, infinite set. The third one is singleton set. Fourth one is empty set. Then we can see equal set, equivalent set, subsets. We have many different types of sets. We'll fastly move to the main concept. Finite set, it will have a countable number of elements in the set, and infinite set has uncountable number of elements. Singleton set, a set has only single element. Empty set, the set does not have any element. And you need to mainly read about this subset. I'll teach you what a subset is. Subset, I'll explain it with an example. It will be easy for you to understand. Let us take a set A equal to 1, 2, and 3. So now I'm going to write subset of A. So what are the smaller sets that you can frame from this set A? First you can take down this empty set, then take this 1 alone, then take this 2 alone, then you can take this 3 alone, then you can take this 1 comma 2 alone, then you can take 2 comma 3, then you can take 1 comma 3, then you can take 1 comma 2 comma 3. So these are the sets framed from these sets, isn't it or not? So these sets are inside this set. So these sets are subset of this set A. These sets are subsets of this set A. And there are also a few other sets like equal sets, equivalent sets, which are not related to this relations and functions. So we will skip into the main concept, relations and functions. So before getting into the concept, that is relations and functions, we need to know about the ordered pairs. So what are ordered pairs? Say for example, this is a classroom and the benches are arranged like this, and in a bench 4 students are sitting. This is the front side and this is the back side. Suppose if a person is sitting here, I have to mention this using the ordered pair. How can I mention? This is first row, second row, third row. I can mention 3 comma, we'll start from here 1. So 1 2 3 comma 2. So this is nothing but ordered pair. In the ordered pair, the first number, that is this coordinate, defines the row, and this coordinate defines the position of the student. 3 comma 2. As you can see, its applications in many places like GPRS and even in cinema tickets, which we usually get in the cities. there you used to get the ticket, and in your ticket itself they will be writing like this: F comma 32 or A comma 15 or C comma 20. What does it mean? You have to take the F row, take the 15th seat. Likewise, clear with this? So these two are called as ordered pairs. 3 comma 2 can be only mentioned as 3 comma 2. It cannot be taken as 2 comma 3, because 3 comma 2 and 2 comma 3 are not the same thing. Third row second seat and second row third seat are not same. So ordered pair should be written as it is. It should not be the coordinates. The first one is called as coordinates. The first one is called as x coordinate. The second one is called as y coordinate, or we simply say it, this as input and this one as output. Okay, so we cannot exchange this. We cannot write it as 2 comma 3 for 3 comma 2. Clear with the idea? And now let us fastly move to this relations and functions. So now we need to know about Cartesian product. Okay, now tell me, why do we use addition, subtraction, multiplication and division in mathematics? What is the purpose of using addition, subtraction, multiplication and division in mathematics? It's very easy to say. We use addition, subtraction, multiplication and division to find new numbers. When we add 1 plus 2, we get another number 3. When we subtract two numbers, we get a new number. When we divide two numbers, we get a new number. So these four are called as operations, basic operations in number work or number system. Likewise, in set language, we have got few basic operations like union, intersection, set difference and complementation, right? So we have a few basic operations on set language also, and these basic operations, set operations are useful to find out a new set from given two sets. ஒரு ரெண்டு செட் கொடுத்துருக்காங்க அப்படின்னா அந்த ரெண்டு செட்ல இருந்து நமக்கு ஒரு புது செட்டை உருவாக்குறதுக்கு இந்த செட் ஆபரேஷன்ஸ் உதவியா இருக்கும். So this Cartesian product is also a method to find out a new set. That's nothing but a multiplication of two sets. Clear? So let me show you how. Let me take set A equal to 1, 2, 3 and set B equal to x comma y. Now I am going to multiply these two sets A cross B equal to what I need to do. I need to multiply each and every element of the first set with each and every element of the second set. You need to write it in the ordered pairs. Likewise, 1 comma x, 1 comma y, then 2 comma x, 2 comma y, 3 comma x and 3 comma y. So this is nothing but the Cartesian product of A cross B. Clear with the idea? This is how we mention. So 1 comma x, 1 comma y, 2 comma x, 2 comma y, 3 comma x, 3 comma y. Cartesian product. Clear? This can even be represented using this arrow diagram. This is set A and this is set B. Take this example 1, 2, 3 and this is x, y. 1 will be paired with x and y, 2 will be paired with x and y, 3 will be paired with x and y. This is nothing but Cartesian product. Clear? So here this 1, 2 and 3, the first set are considered as inputs, the second set are considered as outputs. Okay, so this is nothing but Cartesian product, or we say it as cross product. And A cross B is definitely not equal to B cross A. They are not commutative. Generally, A cross B is not equal to B cross A. But A cross B is not equal to B cross A. But n of A cross B is always equal to n of B cross A. That is, number of elements in A cross B is always equal to number of elements in B cross A. Clear with the idea? Okay. Then, now we will study what is a Cartesian product. Definitions given in your max book. If A and B are two non-empty sets, if A and B are two non-empty sets, then the set of the ordered pairs A comma B. A comma B is nothing but this is considered as A, this is considered as B. So this is considered as A, this is considered as B. The set of all possible ordered pairs A comma B such that A belongs to A, that is this first element comes from the first set, and B belongs to B, that is small b belongs to B, that is this second element comes from the second set. I repeat, if A and B are two non-empty sets, those two sets must be non-empty sets, then the set of all ordered pairs, these are the ordered pairs, all possible ordered pairs must be taken such that this first element A comes from this set A and the second element B comes from this set B. It is called as the Cartesian product of A and B, and it is generally denoted as A cross B. Okay, and in set language form, that is set builder form, it is represented like this: A cross B equal to A comma B, such that A belongs to A, B belongs to B. So it is represented in this form: A comma B, where this element A belongs to the first set A, and the second element, that is this input, comes from A, this output comes from B. Clear with the idea? Any doubt in this Cartesian product? This is the definition of the Cartesian product. Now let us see what is a relation. Let A and B are two non-empty sets. A relation R from A to B is a subset of A cross B satisfying some specific conditions. That is, relation is a subset of the cross product. Let me explain this with your example. Consider two sets, set A equal to 1, 2, 3, 4 and set B equal to 3, 4, 5, 6. Now I am going to do the cross product or the Cartesian product, A cross B. So A cross B equal to, write down all the possible set of ordered pairs: 1, 3, 1, 4, 1, 5 and 1, 6. 2, 3, 2, 4, 2, 5 and 2, 6. 3, 3, 3, 4, 3, 5 and 3, 6. 4, 3, 4, 4, 4, 5 and 4, 6. As I told you earlier, this can even be expressed in the form of arrow diagram, right? How? Take this as a set A and set B. If you put the cross product, you will get 1, 2, 3, 4, 3, 4, 5, 6, 1, 3, like this. You will be getting like this. Again from 2. So you will be getting a diagram like this. So each and every element from set A is mapped to each and every element from set B. So this is the Cartesian product. Now relation. As I told you earlier, it is a subset of the Cartesian product, but it should have some condition. Based on that condition, we filter elements from this Cartesian product. Let us take an example for the relation. Okay, what can be taken? A relation from A to B is considered A plus B should be equal to 8. As you know, the first element is considered as small a and the second element is considered as small b. The relation is nothing but if you add these two elements, you must get the answer 8. So which elements will be selected from this? Not 8. Okay, you can take no issues. So A plus B should be equal to 8. So which elements can be taken? See, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 7. If you come, you can see 2 plus 6 is 8. So take that element R equal to 2, 6. Then you can take this 3, 5. Then you can take this 4, 4. So what I have done now, I have filtered few elements from this Cartesian product or the cross product based on some specific condition. So this is the condition given here, isn't it or not? So this is considered as a relation. Now once again, I'll tell the definition. Let A and B are the two non-empty sets. A relation R from A to B is defined as the subset of A cross B. So this relation is going to be the subset of A cross B satisfying some specific condition. This is the condition given here. if x is related to a, that is a b, if x is related to, here it is taken as x and y, if x is related to a and y is related to b through r, then we write x is related to y, x is related to y, that is this element is related with this element, isn't it or not? Based on some condition, these two elements are related with each other. Clear? So we have few subtopics in this relation which you must know. The first one is the domain, the second one is codomain, the third one is range. So what is a domain, what is a codomain, what is a range? Domain is nothing but the set of all first elements given in the relation, set of all first elements given in the relation. So this is the relation, elements are given here, you have to pick out only the first element. This is 2, you can take this 2, you can take this 3, and you can take this 4. So among these two elements, that is, this should be considered as a one element, among these two coordinates you must take this first alone, and here also you must take the first one alone, and here also you must take the first one alone. Or in other words, we can easily say like this using this arrow diagram, 1 2 3 4 3 4 5 6. As I told you earlier, these are considered as input and this is considered as output. This is set A, this is set B, and this is the relation. So here 2 maps with 6, isn't it or not? 2 maps with 6, and 3 maps with 5, and 4 maps with 4, isn't it or not? So the elements which are involved in mapping from set A, the elements which are involved in mapping from set A is considered as a domain. And what is the range? The elements which are involved in mapping in set B is called as a range, that is 4 5 6, or in other words, in the ordered pair, the second element from the ordered pairs are considered as range. See, two things I have told you. The first one is domain, the second one is range. So what is a domain? The first element from the ordered pair of relation. Or else if you take the diagram, the elements which involved in mapping from set A is considered as a domain. And what is a range? The second elements from this relation, or in other words we can say the elements from B which are involved in mapping is considered as a range. Now what is a codomain? The set B on the whole is considered as a codomain. So what are the elements present in set B? 3, 4, 5 and 6. So these 4 elements are considered as codomain. Okay, domain, mapping elements from set A, range, mapping elements from set B, codomain, the whole set B. Clear with the idea, children? Right. And now and everything of these concepts is explained in set builder form also. You can see x is related to A, that is R. Domain is nothing but R equals x is related to, that is x belongs to A, such that here we have no space, I'll write it here. Domain x belongs to A such that x is related to y for some y belongs to B. See, this is considered as x and this is considered as y. X belongs to A, this x belongs to set A, isn't it or not? This x belongs to this set A, x belongs to A, and x is related to y. This x is related to this y, this x is related to this y, and this x is related to this y, and this x is related to this y. For some y belongs to B, this y belongs to B. Okay, this is domain. And what is the next thing? The next thing is codomain. Codomain of the relation R is B. The whole B set should be considered as the codomain. And third one is range. So what is a range? Range of the relation R equal to y belongs to B. So you are going to take y. This element y will be belongs to B, such that x is related to y for some x belongs to A. That is, now I am going to take only the range. Okay, so this range y belongs to B set. This y belongs to B set, and this x is related to y for some x is related to A. Clear with the idea, pa? Any doubt in the concepts? So these are domain, codomain, and range. Okay, that's all with this. What? Relations. Now we will move on to the next concept called function. It is most interesting concept, functions. So what is a function? A relation f between any two non-empty sets x and y is called a function x to y. For each x belongs to x, there exists only one y belongs to y, such that x comma y belongs to f. To say it in a very simple form, so to say it in a very simple words, for every input there must be one and only output. For every input there must be one and only output. See, it's like a machine. For every input you give, you must get an output. See, there are only two conditions in the function. For every input you must get an output. This is the first condition. The second condition should be, for every input you must get only one output. For example, let me explain this with the arrow diagram. Consider this is set A and this is set B, and here you have got 1, 2, 3 and 4, and here you have got x, y and z. Okay, for every input you must get an output. Okay, I am just going to mark this: 1 with x, and 2 with y, 3 with y, 4 with z. So for every input, so as I told you earlier, the set A is considered as input, set B is considered as output. See, for every input you are getting only one output. You are not getting two outputs at a time. So for 1 the output is x, for 2 the output is y, for 3 the output is y. See, though this 2 and 3 gets the same output, 2 gets only one output, 3 gets only one output, and 4 gets only one output. So this is nothing but function. So what is a function? For every input you must get one and only output. Only one output you must get. You should not get more than one output. See, you should not get like this, 1, 2, 3, and here you can take 5, 6, 7, 8. Let me take like this. See, this 1 is mapped with 5, 2 is mapped with 6, 3 is mapped with 7, 3 is mapped with 8. It is not possible. This is not a function, because this element 3 has got two outputs. The one output is 7, the another one output is 8. Clear with the idea, pa? So what is a function? So a function is a relation between two non-empty set x and y. It is called a function from x to y. If for each x from x, if for each x from x, this is taken as x and y. So each x from x, there exists only one y belongs to y. There exists only one y belongs to y. Clear with the idea? Such that x comma y belongs to function. If you get only one output for one input, then it is considered as a function. So that's all with this relations and functions. And we do have many types of functions, such as one-to-one function, on-to function, into function, constant function. We have got many types of functions. In the next class we will see about the types of functions. Clear? I would like to say few extra points from this Cartesian product, relations and functions. So now let me take this bigger circle as the Cartesian product. Okay, now this is nothing but relation. So it's clearly seen that the relation is the subset of the Cartesian product based on some specific condition. And once again, functions, it is the subset of relation. So function is a subset of relation, relation is the subset of the Cartesian product, and this function, for every input you get only one output. Clear? So function is the subset of relation, relation is the subset of Cartesian product. In relations, you can have one or many outputs for a single input. Okay, but in functions you must have only one output for an input. So let me draw a diagram and explain it to you. 1 2 3 4 5 6 7. Let me draw like this. Is this a relation? Yes, of course this is a relation, because it is a Cartesian, this is a subset of a Cartesian product. Based on some conditions, this mapping has been done. That's all. So this is definitely a relation. It is a subset of a Cartesian product. The question is whether this is a function. This is definitely not a function, because the element 2 has got two outputs. So which can be taken as a function? 1 2 3 4 5 6 7. 1 like this. This can be taken as a function. See, for every input you are having only one output, isn't it or not? So you should not have two outputs. See whether this can be left as it is without mapping. Yes, of course. In set B, see, in set B there can be an extra element, there can be one or two or many extra elements without mapping. But in set A, all the elements must be mapped with set B. Suppose if you are left here with an element 4, then this is definitely not a function, because as I told you, for every input there should be an output. So this 4 should have an output in order to be a function. Clear? Let me give you a real life example for explaining this relations and functions. Consider you have got 1 liter of petrol in your tank, that is in your vehicle tank. So which are the places you can go? You can go to many places, multiple of places, isn't it or not? See, you have got only 1 liter of petrol. Using this you can go to many places, place A, place B, place C, place D, place C. You can go to many places. I'm just naming it as alphabets. You can just add some names if you want. So you can go to multiple of places. So this is the best example for the relations. And for the functions, consider an ATM machine. Okay, consider an ATM machine. Suppose if you are inserting your card and if you are entering the value of rupees 100, you will be getting only 100 rupees. Suppose if you are entering the value of 200, you will be getting 200 rupees. Suppose if you are entering the value of 10,000, you will be getting only 10,000 rupees. So when you enter 100, you will not get 100, and you will not get, at the same time you won't get 100 and 200, you will be getting only 100 rupees. So for every input you will get only one output. This is the best example for the relation. So now we will study about the different types of relations. There are many types of relations, like empty relations, then we have got reflexive relations, symmetric, then transitive, identity, inverse, and what else? Universe, inverse and universal relations. And you will study about these concepts in your higher classes, especially in +1. And there are also many types of functions. Say for example, a one-to-one function, then many-to-one function, one-to-one and on-to, then into function, neither one-to-one nor on-to, quadratic, linear function, linear function, then a rational function, modulus function, etc. So you will study few of the types of functions in the 10th standard, and the remaining things you will be studying in your higher classes. Okay, so these are the types of relations, and these are the types of functions. See, the main purpose of studying these relations and functions is to study the higher concepts in mathematics and in science without any difficulty. Actually, its applications are widely spread throughout the mathematics, not in a single chapter. It's widely spread throughout the mathematics in many chapters, especially algebra, probability, differential calculus, integral calculus, Boolean algebra. Actually, Boolean algebra is mainly used to design the electronic digital circuit. You might have heard about this, which is found in calculators and also in computers. And these relations and functions are useful in drawing the graphs. Okay, see, each and every formula is a function. Suppose if you are taking the circumference of the circle as c is equal to 2 pi r, so this is actually a function. When the radius increases, the circumference automatically gets increases, isn't it or not? This is actually a function. So these relations and functions are useful in framing the formulas, finding the relationship between any two units. So in real world situations, these functions are the mathematical representations of many input and output situations. They are actually mathematical building blocks for predicting the natural disasters, finding the temperatures, to understand the world economics, demand and supply chain, designing the missions. It's mainly useful in designing the missions where input and output is mainly used. Airplane industries, medical industries, and even in the forensic departments it's widely used. I think there is a problem related with this forensic department also in your textbook. Okay, so its application to the real world situations are not limited. It is useful in many fields, either directly or indirectly, and it is also useful in logistics. See, you can never be in two places at a time, isn't it or not? So if you plot the graph where these two peoples as a function of time, these two lines will meet at a point. So that is nothing but the meeting point of those two peoples, isn't it or not? So this concept you can use in logistics. Okay, this concept is mainly used in logistics. And if you draw the graph for it, the place where this line meets, these two peoples will meet each other. Easily you can use this concept in logistics, and even in thermometers, isn't it? In thermometers, there are two types of thermometers. We use the Celsius thermometer as well as the Fahrenheit thermometer, isn't it or not? In India we use Celsius thermometer. If you take US, United States, they use Fahrenheit thermometer. If you take the function f is equal to 9 by 5c plus 32, see, this is a function to convert from Celsius to Fahrenheit or from Fahrenheit to Celsius. This is also there is a sum given in the exercise relating with this conversion of Fahrenheit to Celsius and Celsius to Fahrenheit. And the concepts of relations and functions is used even in the soda machines, ATM machines, especially in machines. See, think of any process where an input produces an output. That process is called as a function. It is not limited to just one field. Clear, children? So children, I hope you have learnt about the relations and functions in detail. And relations and functions is one of the easiest, and at the same time it is a mass scoring chapter and an important chapter for your public examination. You will get at least 2 5 marks and 2 marks from this chapter. So I want you all to understand the concept clearly and practice it properly. So all the very best, children. Take care and bye.